Hello everyone, I am Engg and I welcome you all in this lecture of Engineering Graphics and Design. Our chapter Orthographic Projections and Sectional Orthographic Projections, in which today we will discuss about one example regarding sectional orthographic projections. Now for the given figure, draw sectional front view along X, top view and left hand side view using first angle projection method. So this is one pictorial view of the 3D object. The X direction represents the position of the observer. In this object, first of all, we have to find out all the dimensions for the particular part. Suppose here there are two holes. This hole of radius 14. The hole is start from top up to and end at bottom. Now, this hole of radius 11 and this is a semicircle of radius 25. The center of hole and semicircle is same. Here also the center for this circle and this semicircle is same. Okay. Now this is 30 mm length for this rib and the thickness of the rib is 10 mm. The height of this part is 30 mm and height of this part is 15. So total height is 30 plus 15. Now what is the overall length? So this is radius 25. Then 45 distance from this center to this line plus 20 mm and plus 25 mm. So total length 115. What is the width? So you can see the width of the object is 50 mm because width means it is a diameter of this semicircle which is 25 mm radius. So 50 mm width and height 30 plus 15 means 45. So first of all we have to draw the orthographic projections, front view, top view and left hand side view. Then we use the cutting plane like vertical cutting plane, cut the object and then we will draw the sectional front view, top view and left hand side positions for view using first angle projection method. So first of all draw one XY line and perpendicular X1 Y1. Front view which represents length and height, top view represents length and width, and side view represents width and height of the object. Draw three rectangles using length, width and height and by using 45 degree. So these are the blocks for front view, top view and left hand side view. Front view is rectangle of length and height, top view length and width and left hand side view, this is width means 50 mm and height 45. Now when we observe the object from top, we look the object in symmetrical about horizontal line. So whenever we start any view, we have to observe first in which view our object is symmetrical. So here our top view is symmetrical about horizontal line. So start your top view by drawing a center line. So this is a center line in 3D. The object is symmetrical about this line. Now the semicircle, this part is semicircles and top view it looks true. Before that, we have to draw two vertical center line which intersect this horizontal line. Now these two centers are center of the circles. So the distance between two circles is 45 plus 20 means 65 mm. So this is 25 mm, 65 and 25. Now take the center 25 mm radius and draw one semicircle. Similarly, center 25 mm radius, another semicircle. Draw full circle of radius 11 and full circle of radius 40. Draw two horizontal lines for this portion. Now draw vertical line which represents the top view of this plane. Draw two horizontal lines which is top view of this surface. Now rib. Top view of rib looks a rectangle in which length of the rectangle is 30 mm and the height of the rectangle is 10 mm because 10 mm thickness is given. Now for front view, we have to draw first projection lines from top view and start the front view of base. So base is one horizontal line. Now front view of this right side edge, front view of top surface. So length of this line is 20 plus 25. Now front view of this part, the top view is given here. The front view of height 30 mm, so we have to draw vertical line 30 mm down. Then front view of this horizontal surface looks horizontal line in front view. And front view of this end of the semicircle part. Now front view of this hole and this hole hidden. Draw the front view of rib. So you have to extend this line up to this. Now what is the front view of this line? Here. The front view of this line is here. And front view of this surface, because the surface of the rib is inclined to H plane perpendicular to VP. So it is only line. Front view of the circle by taking center line and projection hidden line. So because this is a full front view, this is not a sectional view. From front you cannot see the hole, so it represented by hidden lines. Now for side view, you have to extend this line up to 45 degree and vertical line and horizontal line from front view. This is the position for left hand side view. First of all, you have to draw this bottom base, which is 15 mm height. So length of the side view is 50 mm and height 15 mm. And draw the side view of this part and this part, and also top surface horizontal line. Now what about rib? From left hand side view, the rib shown rectangle. So you have to extend this two line from front view and extend horizontal line and vertical line from top view. You will get the left hand side view. Now these two holes are also hidden in left hand side view. The height of this hole 15 mm and height of this hole is 45 mm. So you have to extend horizontal line from top view and vertical line, and show the hidden lines which is 15 mm height. For this hole, draw horizontal and vertical lines. So this is front view, top view and left hand side view. Up to this we work on orthographic projections. But if you want to draw the sectional front view, so for sectional front view, whenever you observe front view, that time you have to cut the object from a plane which is passing through this line. Okay, and for every sectional front view we have to use vertical cutting plane. So if you cut the object with cutting plane, and if you remove this half portion and observe the remaining half, then at that time the hole is visible, these two holes visible in half portion. So for this sectional front view, we have to use this cutting plane, and the cutting plane shown in top view AA, and in cutting plane for left hand side view is AA. Now sectional front view, in which the hidden line become full and this hidden line also become full. But the cutting plane is passing from the surface which are under cutting. It represented by hatching line or section. So we have to use section line which is always 45 degree, and the distance between these two section line is approximately 2 to 3 mm. Here there is no material, so cutting plane is not passing from any surface here and also here. That's why there is no section line drawn here. So you can try for more problems yourself and draw different sectional views using different cutting planes. Okay. Thank you very much for watching this video.